I would like to express my thanks for the organizers of the ICCF 23 conference in China to give us this opportunity to talk about our research in the area of cold fusion, which is also called as low energy nuclear reactions. We at the Center of Energy Research at SVASA are the only entity in India pursuing this research, and we are very optimistic and hopeful about LENR becoming a reality. Many countries in the world are carrying out research and experimentation to optimize and harness the excess heat generated in their respective experiments. Traditional methods of calorimetry is very popular in measuring this excess heat. However, there are many third parties still debating and questioning the measurement process itself and its accuracy. This needs to be addressed. Even consistency of results in their experiments and repeatability elsewhere are yet to be accepted. Results from China, Japan and Russia are being referred to regularly, though there are likely to be other success stories as well, not well advertised or documented. Dr. Mizuno from Japan has made an open offer for anybody to replicate his results and make improvements. We at the Center of Energy Research at SVASA University is happy to share LENR results which are consistent over more than 2 years. In phase 1, air calorimetry was attempted in similar lines as Dr. Mizuno has shown in slide number 4, wherein the reactor is positioned inside an insulated box and output heat is measured using an air calorimeter. The measurement of heat coming out of the reactor is measured under identical conditions, both for calibration without an active fuel and subsequently for excess heat generation with an active fuel for true comparison. Both the pictures in the slide show two views of the air calorimeter. Slide number 5 shows one typical result of generation of excess heat in a nickel, palladium, samarium, deuterium system as a function of input power both for calibration run and active run. The graph is also generated for two values of blower input power, 5 watts and 16 watts. Active case output shows proportional increase in output power for increased blower input powers. The blue line in graph indicates calibration output as a function of input power. It is seen that this output does not vary much with input power to blower. Black and red lines show output power in active case as a function of input power for different blower input powers. The output power in all the cases here is measured using air calorimeter. Based on the concern about inaccuracies in measurement of airflow using either hot wire anemometer or turbine anemometer, an attempt has been made by avoiding airflow measurements altogether. An adiabatic test setup has been created with an insulated box sealed completely. The reactor loaded with fuel is positioned inside the box and only temperature measurements are carried out to be more consistent and accurate. The surface temperature of the reactor was recorded both with palladium as fuel and without palladium, while nickel mesh was used in both the cases. It is seen that the skid temperature stabilized at 19 degrees centigrade, higher when compared to calibration, showing even the core temperature has gone up. The core temperature has gone up for the same power input condition. Being an insulated sealed chamber, this has been titled as an adiabatic test by us. Attempt has also been made to mathematically estimate the skid temperature for the 50 watt power input to the heater. It is observed that the skid temperature of the reactor is higher than the value at calibration test, and the excess heat of about 25 watts accounts for the higher temperature of the reactor skin, which could only have been generated inside the reactor stock. Thus, 50% excess heat has been observed both in measurement and through the mathematical model, thus assuring a high degree of confidence in the experimental procedure. Slide number 7 shows the adiabatic experiment, how it has been carried out. For calibration, the reactor is in a sealed, thermally insulated box. Inside the reactor, we have untreated nickel mesh and deuterium gas. Temperatures of reactor skin and wall of the box were recorded for verification. In active experiment, untreated nickel mesh is replaced with treated nickel mesh with palladium followed by samarium nanomaterial. Everything else being the same as in the calibration experiment. Slide number 8. This shows the table where the skin temperature of the reactor indicates 19 degrees 19 Celsius higher value when compared to calibration run. This adiabatic test was carried out and measurements done after allowing sufficient time for the system to reach steady state temperature both on reactor body and inside surface of the seal box. In addition to higher skin temperature, the core temperature at the heater location also had gone up slightly from 276 to 302 degrees Celsius for the same heater input power of 50 watts. This also indicates generation of additional heat inside the reactor when compared to calibration condition. Slide number 9 shows table containing typical result covering both calorimeter based and adiabatic experiments for comparison. In both types of tests, The excess heat is seen whenever active material is inside the reactor when compared to the measurements carried out without active material. The table shows, of course, the data compiled only for a 50 watt heater input condition. Slide number 10. This slide summarizes the measurements done over more than 1 year, demonstrating consistency of measurements of excess heat even when the reactor hardware and its contents were changed to demonstrate repeatability and consistency. We did arrive at a conclusion after experimenting over the last 2 years that the difference in excess heat was not substantial when the hydrogen gas inside the reactor were replaced by deuterium gas. We could arrive at a different method of measuring and verifying the excess heat generated in low energy nuclear reactions as presented in this paper. The paper also demonstrates repeatability and consistency in these experiments. The CR team is, of course, continuing the research to enhance the efficiency and quantity of excess heat as early as possible. We would like to thank you, the conference organizers, for the opportunity given for presenting a paper in ICCF 23, and also the organizers from Xiamen, China. Thank you very much.